Solve two-step equations. This is an example of a two-step equation. The reason why it's called a two-step equation is because there are two operations happening to the x. X is being multiplied by 2 and added by 3. I'm going to use the properties of equality to solve for x. First thing I'm going to do is cancel out this addition of 3. So I'm going to undo it or cancel that by using the opposite or the inverse of addition of 3, which is subtracting by 3. So I'm going to subtract, and I'm going to use a vertical format, meaning going straight down in this form right here. So the equal sign is kind of like my cutoff position right here to show me the left and the right. So the property of equality says if I do an operation to the left side, I have to do it to the right to keep it balanced. So here I end up with, on the left, I will end up with a 2x equals, and then on the right I have 7 minus 3, which is 4, leading me to my second step. I have this 2 being multiplied by this x. I want x by itself. So the inverse of multiplying by 2 is to divide by 2. So I'm going to divide by 2. And again, the division property of equality states I have to divide the other side by 2 as well. So I divide 2 by 2, leaving me with my x all by itself like I want it. And then 4 divided by 2 is 2. So this is the answer to my two-step equation. I can always check my answer by replacing this 2 back into our original equation and working it out to make sure that the left side equals the right side. Here is another example of a two-step equation. It's just in a different format, but I know it's a two-step equation because here is my variable n, and n is being multiplied by this number 1/4 and subtracted by this number 3. So two operations, two steps. I still want to use my properties of equality, so I'm going to draw my line here to let me know my left and my right side. And I want to isolate for n on the right. So first I'm going to cancel or get rid of the term that doesn't have the n, so that is this minus 3. So the opposite or the inverse property of subtracting 3 is to add 3. So I'm going to add 3 to this 3. Now the property of equality, subtraction property of equality states whatever I do to one side, so since I'm adding 3 on the right side, I have to add 3 to the left side to keep it balanced. So these things cancel out. Minus 3 plus 3, you see how they're opposites? They cancel each other out, leaving me with 1/4 n on the right equals, on the left I have 25 plus 3, which is 28. Now I have 1/4 times n. So I have this coefficient, a rational coefficient of 1/4, and I want to get rid of that or cancel that. So what I'm going to do is actually multiply by the multiplicative inverse. Multiplicative inverse is just the reciprocal of 1/4. So I'm going to multiply 1/4 to both sides of the equation. So I'm going to multiply by 4/1 over here and 4/1 on this side. And I really don't need the 1 since 28 is not a fraction, but just so you can see it, I'll put it there. All right, so inverses cancel each other out just like in the previous step. So the 4's cancel or divide out, leaving me with my n all by itself. And over here, if I wanted to be, okay, so let's go ahead and cancel this out. 4 and the 1's cancel out, leaving my n by itself. And over here on the left-hand side, I multiply 4 times 28, and I get 112 over 1, which is just 112. So n equals 112. Here is another two-step equation. I identify once again, here's my variable, and there are two operations happening here. And it's a little different identifying it, I know that 3 is being multiplied times this x, or actually a negative 3 is being multiplied times this x. And then we have this 6. And we're like, what's happening with the 6? There's no sign or anything. But if I were to switch this around, the 6 will actually be adding to this x because it's a positive 6. Okay, so basically in my mind I can see it like this. I'll show you. Negative 3x plus 6 equals 21. These are two equivalent equations. All I did was use my commutative property of addition, meaning I can change the order and keep it the same. But let's just leave it how it is and solve from there. Okay, so the first step is for isolating our x, is to cancel out the term without the x, which is our 6, and it is a positive 6. So the inverse operation of positive 6 or adding 6 is to subtract 6. So once again, let me draw my line to clarify the sides I'm on. So on the left side, I am subtracting 6, and my property of equality, or my subtraction property of equality, states I need to subtract 6 also from the right to keep it nice and balanced. So the 6's cancel out. 6 minus 6 is 0, or gone. And which leaves me, this is very important, leaves me with that sign right there in front of the 3, leaves me with the negative 3x right there on the left hand side. And on the right side, 21 minus 6 is 15. So I get negative 3x is equal to 15. And now I want to continue isolating for x. X is being multiplied by negative 3. So the opposite of multiplying by negative 3 is to divide by negative 3. So the property of, or the division property of equality states that if I divide the left side by negative 3, I need to divide the right side by negative 3. So that gives me my x by itself, and a positive 15 divided by a negative 3 gives me a negative 5 for my answer. So x is equal to negative 5. Well, I hope you found this video helpful and informative. Here's some key terms, or some terms that I use in the video that you could look up if you need to find their definitions. All right, well, good luck.